Hey guys, grade 12 trigonometry. Cool. We're going to start with compound angles identities. That's number one. Number two, I'm not going to do the proof. However, if any of you would like me to do the proof of these identities, I can make a video and post it. Just let me know. And also any other thing. So like we're starting from compound, right? Angles identities. And any other thing that we're not going to talk about in all these videos, you can find it in grade 11. All right, so if you want a proper revision, grade 11 videos quite helpful. Cool, so let's start. So these things now, I don't know, I am not sure. So the thing is, for course, here's how I used to remember them. Should it happen that because sometimes you are writing and it's gonna be a bit challenging to remember these things. You can easily sometimes forget, right? So I know for course sign changes, right? And then the sign stays the same. So for cos you're gonna have cos alpha, cos beta, right? Okay, let me just write sine here, sine alpha, sine beta, cos alpha, cos beta, sine alpha, sine beta, right? So the sign here, it changes. It's a minus, therefore it's a plus here. It's a plus, therefore it's a minus here. And then for sine, right, you have sine alpha, cos beta, right? And then for the signs they stay the same. So it's a minus that side, so we're gonna have a minus this side. And now it was a sine alpha, now it's gonna be cos alpha, sine what? Cos alpha, sine beta, right? And then here same thing. Right, then it's a plus because we have a plus. Right, so these are just all the identities for compound angles. Right, with this, let's go and do a couple of examples now. They say show that show that sine 75 is that so the trick is remember there's only one group of angles which you can try to solve without using a calculator, and it is special angles, right? So special angles, we are talking about 30 degrees, we are talking about 45 degrees, we are talking about 60 degrees, right? I mean, we can include 90 as well if you want, but yeah. So we are talking about these angles. Let me just say these three angles, right? Whenever we're talking about special angles, right? So now you look at this sign and you're like, okay, is there any way in which I can write 75 in a form of special angles kind of thing? Yeah. And of course there is you add these two together, they give you, if you add them, you get exactly 75 degrees. So you can say sine 30 plus 45 degrees and here it doesn't really matter. You can start with sine 45 plus 30 degrees or sine 30 plus, like I did. It doesn't really matter. So we continue. Sine, it's going to be, you have sine alpha. Okay, let me not say alpha. Alpha in this case is 30, so you have sine 30 and then cos 45 degrees and then the sign is plus, so we have a plus. Then we start with cos, so now it's cos 30 sine 45, right? To verify, let's check with the identities, right? You see we have sine alpha, cos beta, alpha beta, and then plus, then it's cos beta. yeah, cos alpha sine beta, right? So that's how it's done. And now it's just about you remembering your special angles. For me, I always go to my triangles. I know if I have a 30 degrees here, this is 1, this is 2, and therefore this is square root of 3. And I know also here, if I have 45 degrees here, 45 degrees here, of course this is gonna be 60 this side, my 90-degree angle. So I'm gonna have 1 1, and I'm gonna have square root of 2, right? So from there on, you just do your thing, bro. Sine 30, it's 1 over 2 multiplied by cos 30, no, cos 45, it's 1 over square root of 2 plus, right, cos 30, it's square root of 3 over 2 adjacent over hypotenuse, multiply by sine 45, 1 over square root of 2, right? So yeah, let's try to rationalize these two, right? So if you rationalize these two, I guess you can multiply everything by square root of 2 over square root of 2, multiply by square root of 2 over square root of 2. We're gonna have 1 over 2 multiply by square root of 2 over 2, and then you're gonna have a plus, because it's a plus here, so you're gonna have a plus, so this is gonna be square root of 3 times square root of 2 over 2. Wait, let me do it step by step, bro. So I have square root of 3 over 2, and then times square root of 2 over 2. Alright, so that's what I have. And then cool, it makes sense now. So now I can just say that I have square root of 2 over 4 plus, right, plus square root of 3 multiplied by square root of 2 over 4. Right, I have the same basis, I have the same denominators, right? So that means then addition is possible, right? So if now addition is possible, I'm gonna end up with something like this. I'm gonna end up with square root of 2 plus, and then I have 4 here, right, of which I have a common factor here. Then I have, if I take it out, that common factor, which is square root of 2, I end up with 1 plus square root of 3 all over 4, right, which is we have it square root of 2, 1 plus square root of 3 over 4, right? Exactly what we were tasked to do. Let's go for more examples. So they ask you without a calculator, find these. So you're gonna do exactly the same thing now, right? You have your angles 30, 45, and 60, right? And I'm saying I think 45 plus 60 has to, there we go. So here you go again, you like sine 45 plus 60, right? Let's forget about the space. So it's gonna be sine 45 and then cos 60. Okay, let me have my triangles. I'll have them right here. So I have 30. Okay, I'm not okay, I have 60. I have 1 2 square root of 3, and then I have, of course, 90 degrees 1 1 square root of 2, 45 45. So sine 60 cos 60, cos 60, then it's a plus cos 45 sine 60. Now sine 45 is 1 over square root of 2 multiplied by cos is adjacent, which is 1 over 2 adjacent time over hypotenuse, and then I have a plus. Cos 45 is 1 over square root of 2, and then by the way, okay, yeah, and then we have, what is this? Yeah, sine 60, it's gonna be square root of 3 over 2, right? So eventually, or overall, I end up with 1 over 2 square root of 2. Let me see, that was sine 45, which is adjacent over cool, and then a plus, right? Square root of 3 over 2 square root of 2, right? Which, I mean, you can just say square root of 3 plus 1 over 2 square root of 2. Let's see. Sine 105. We do sine 105, we get here can they rationalize this thing? Yeah, so yeah, here they rationalize this thing, but it's the same value, right? Just press your calculator, or perhaps I'm gonna put this value on my calculator. I need to get 0.965. Remember, 965 965 965 965 0.965. You see, cool stuff. And then if I do the workout for number 2, right, for number 2, it's gonna be something like, I know for sure 45 minus 30 gives me 15, right? So for number 2, I will say I have cos 45 degrees minus 30 equals to cos 45 sine, no bro, oh yes, oh, now we're talking about cos, of course. So cos, remember, cos is cos, sine, so it's cos 45 cos 30, then the plus, then therefore here, no, it's minus, therefore here it's plus, and then we have sine, so it's gonna be sine 45 sine 30, right? And then cos 45, I know it's 1 over square root of 2, and then cos 30, it's adjacent over hypotenuse, so it's square root of 3 over 2, right? And then I have a plus. Sine 45, it's 1 over square root of 2, sine 30, it's 1 over 2, and now it's just me multiplying. I have square root of 3 over 2 root 2 plus 1 over 2 root 2, which is kind of like the same angle. It's like the same value as we had last time, right? Because we are still getting, you see, it's gonna be square root of 3 plus 1 over 2 root 2, right? Over 2 root 2. Yeah, so if I ask you anything, we see that these two give us the same value now. So now this is me testing you guys, like how good is your revision, or like how good is your memory of what you guys learned in grade 11, I think. Yes, that must have been in grade 11. So why, can anybody explain why these two are equal? So I will remind you, remember we have this thing of core functions. We talk about sine 90 plus theta being equal to what, right? Cos theta, right? So now we have like something like sine 90 plus what, right? You go 105 minus 90, you get 15 degrees, right? Which will be cos 15, right? So that's this is why they are equal. Cool stuffs. Alright, so I don't know, maybe we might need these triangles, ne? of our special angles, so I'm gonna move them up. I'm gonna promote them. Cool. We're doing this one now. So look, you see it's cos cos sine sine, therefore it is cos. So then you have, and then this is alpha and this is beta, alpha beta, right? So therefore you can say that thing is gonna be equals to cos, right, alpha, right, and then beta, right? And then as for the sign, this sign, right, as for the sign, it's a what, it's a minus, therefore here it must be a plus. So we are looking for cos 60, right? And cos 60, what is it? 1 over 2, right? 1 over 2. We test it out. We like, okay, give me cos 20 multiply by cos 40 minus sine 20 multiply by sine 40, right? You get 1 over 2, 0.5. You see, so cool stuff. So we have another nicer one here. This is alpha beta, and you also seeing it's cos cos, a sine, so therefore it's gonna be also cos. So you have cos 45 minus x, so it's a minus here, therefore it's a plus, and then x, right, which is cos 45, which is 1 over square root of 2. All right, that's how these things goes. Yeah, that's how they go. Let's do a couple of proofs here for these. Yeah, let's do a young workout on these ones. Yeah, so basically we are just proving, right, we're gonna prove these identities using the using compound angles. So we look, you have sorry. Okay, so you have sine 60 minus x plus sine 60 plus x. We have to prove that is equals to that, so we will just say I think green is okay. Left hand side is gonna be, so 60. So for sine, remember we have sine what? For 60, no, for sine it's a sine cos, no, sine cos sine, yeah, so it's gonna be sine 60 cos x, then we have a minus, therefore it's gonna be a plus, and then you have cos what? Cos 60 sine x, right? Then we have, oh no, bro, the signs, it's a negative, therefore it's a negative. The sign, they keep the sign. Yeah, when it's a sign here, the sign doesn't changes. It's, yeah. So coming to this one, we're gonna have a plus sine 60. We have a sine 60 cos x, it's a plus, so we have a plus cos 60. Cool, I'm running out of space. Cos 60 sine 45. No, sine x, hey. So this will be cos 60 sine x. It's fine, bro. You guys just know that is sine x. So now I'm gonna prove that these are like, damn, I didn't need the calculator either way. So now I'm gonna prove that damn, what am I saying, bro? Shit. Now I just saw something and it distracted me a bit. What I will do is I'm gonna group them together. So we have the sine, we have the sine, we have the cos, we have the cos. So I'm gonna group them together. And yo, my king. Yes sir, yes sir, yes sir. The students are being fed. What are you teaching my students? Okay, so, and I have another sign here, ne? Oh, yeah, I have another sign there. I mean, here, actually, I would say it's just a matter of you, like how you prefer to solve these things. Sine 60 cos x, right? And then I'm gonna have minus cos is 60 sine x plus cos 60 sine x. So these, they will minus, and here we're gonna get 0. It's gonna be 0. And then here you're gonna have 2 sine 60, right? Sine 60 cos x. And then sine 60, you know, on your triangle you have 30, 1, 2, square root of 3, and this is 60. So sine 60 is square root of 3, so you're gonna have 2 square root of 3 over 2, right? That is, and then you have your cos x, and then these two, they cancel, right? And then you have square root of 3 cos x, right? And that's it. Let's do this one. We might need special angles here, so I'm gonna throw them up here. 1, 2 square root of 3, 60, 30, 1, 1 square root of 2, 45, 45, 90. Cool. So about this one, hence evaluate. Oh, okay, so you guys see we proved these to be that, and then they say hence find this without a calculate. So now you see this, we can say sine 60 minus 45 plus sine 60 plus 45 degrees. So this is this, and that is that, right? So we saw that this thing, right, in our working we have 60 and we have x, so that means we're gonna have what? We're gonna have square root of 3 cos 45 degrees, right? Yeah, we'll prove that it's square root of 3 cos x, and this is x, this is x, so x is 45 in our case. So yeah, and then cos 45, so you have square root of 3. Cos 45 is 1 over square root of 2, which is square root of 3 over square root of 2, right? So let me see if I can do a multi-window. Cool. So now I'm gonna test sine 15 plus sine 105, and I am getting square root of, right, which is, in a way you can say times square root of 2 over square root of 2. This is a square root of 6, or square root of 3 times times 2 inside 1, and then this is just gonna be 2, which is a square root of 6 over 2. So we are killing this thing, bro. We are killing this thing. Let's do the last example. The last example here we have these two. So look at it. Cos. Did I actually do a mistake, or is it supposed to be like this? I need to check that. Alright, cool. So everything is fine here. No mistakes done. So how do we then approach this one? You see, we have 65, we have 35, we have 25, we have 55. None of these angles look anything yeah, anything like similar, yeah. But here, if I say, let me see, 90 minus 25, so 90 minus 25 is 65. I have 65 here, and if I say cos 90 minus 25, it's gonna give me sine 65, right? And then I have 20. Damn. No, it's gonna give me sine 25, right? It's gonna give me sine 25, and then I have a cos 25 here. And the same is true also, like if I say here sine 90 minus 35, let me say 55, I get 35, right? So it just depends on me. How do I want to play it, né? How do I want to play it? In fact, how do I want to play it? Okay, I'll give you two ways and I'll just choose my way. So here you can say you have cos 90 minus 25, right? And then cos 90 minus 55, right? Then this one you just write it as it is, that it's cos 25 cos 55, because now this is gonna be sine 25 yeah, wait, and this is going to be that is going to be also sine 55. But remember, the signs could be tricky. Yeah, so remember 90 minus theta is in the first quadrant, of which all angles are positive, so you will have it like this. Then you have plus cos 25, right? Cos 55. And when it's like this, this is alpha, this is beta, this is alpha, this is beta. And in fact, right, since it's a plus, you can write it this way. And you can write it this way because it's a plus. So now you see it's cos sine, right? So when it's cos sine, you know for sure what do you have there. You have cos 25, and then the sign. What happens about the sign? Does the sign, it's positive here we know it's gonna be negative, right? Yeah, which is then cos 25 minus 55 minus 30, right? And you know, by negative angles, cos is the only one positive, so you have cos 30, right? And cos 30 is equals to what? Adjacent, it's equals to square root of 3 over 2. Just want to verify with the calculator. So you have what do you have? Cos 65 cos 35 plus cos 25 cos 55. Oh, come on, bro. Okay, so we're getting 0.866 square root of 3 0.866, You see, so we're good, bro. We're good. So the other way someone could look at this is so remember this time we changed this side, right? We changed this side, right? So now we're gonna try to change the other side. We're gonna try to change the other side. So they can say, okay, we have cos 65 cos 35 plus cos 90 minus 65 cos 90 minus 35, and then you will have cos 65 cos 35 plus, this becomes a sign and a positive sign, so sine 65 minus not minus, multiply by sine 35, right? We do the math here, it's still cos sine, so then from cos it's gonna be cos 65, it's a plus, so you have a minus 35, right, which gives you a positive cos 30, right, which gives you that square root of 3/2. You see, and just like that we are done. This is the end. I hope it was helpful.